people out of how many people got an A
Is there
would be my
anyone who
first
still
question.
wants me to, kind of rephrase the question, probably using some easier words?
So is it not clear because you don't have the baseline for the second amount? Like you don't have the total amount of students.
Brendan, are you here?
Am I not talking?
I don't think you can hear us.
Can you hear me, Brendan?
Can you not hear me? No?
I guess he's not here. Rachel?
I'm here.
Oh. Yeah, I'm here.
Yeah, I don't think he can hear us.
Oh, okay, yeah. I can hear you now. Sorry.
Oh, you're good.
Okay. So, is this a useful comparison? I mean, forget about the question, the problem I mentioned.
Is it? I would say it's not a useful comparison because we don't know how many students compared between the two, if that makes sense. So you have 20 students got an A in the last semester, but we don't know of how many students that is. You know, it could be 20 out of 40 or it could be 20 out of 21. And then in this case, it increases by 3, or what was the second part of it?
Oh yeah, it's all right. It increased by 3 or it got dropped by 3. It's actually the same thing. Yeah. Yeah, you're right. So the basic thing here is you need to know the whole amount, or at least the percentage. If I just say it got dropped by 3 or by some numbers, it may not be enough. It's kind of ambiguous. It's kind of um, giving you it could give you a false interpretation, simply because, just as you said, we don't really know of how many students we are actually comparing these two results, right? So yeah, that's right. So for this particular problem as well, we don't really know again of how many students there are, how many students we had the previous year and how many students we have now. So that means this decrease by 17 doesn't really make any sense. We can't really use it for a good comparison. It's not really that useful. It's not really significant since we don't know. So the reason I'm doing this question is often the question doesn't give you complete information. It doesn't have all the information you need to interpret the final result. And that is really important. I guess I'm repeating myself, but adding one word extra or just ignoring one word from the question would actually lead you to something completely different. So again, yeah, that's a very good explanation. So this is not a useful comparison since we don't really know how many students we had and how many students we have now, because this 17 could be out of 20, could be out of 200, could be out of even 1,000. So this is not a good comparison. And the last one said, considering the last sentence, can we conclude that the number of dropout factories was originally 34? Okay, what was the last sentence? The number of kids attending schools with such low graduation rates was cut in half. Okay, now what can we what are the informations can we derive from this? That's the first thing. Again, the question says the last sentence of the question was the graduation rate was cut in half. So does this mean it was originally 34 since it got decreased by 17? Just think about it. Use your intuition. Don't straight away go for hard and fast rules. Just try to see what are the informations you have and can you relate those and find out that yeah, this was actually 34, or no, we don't really have this information to finally make a conclusion that we had 34 or something like that. Just try to think, what can you get from this? Anyone? Don't look at the solution first. Emily, are you here?
Yeah, I'm here. I just don't really understand what you're exactly asking.
Okay, can you see the question? Example 8b.
Yeah.
Okay.
So.
Yeah.
Yes, we can conclude that. I don't know.
Okay, yeah, that's fine. That's fine. Even if you're wrong, I have said it a couple of times before that even if you're wrong, you should try because we are actually here to learn. So if it's wrong, that's fine. We can um, make things clear afterwards. So why do you think that the dropout factory was originally 34? What made you think that?
Well, I guess I don't really know. I haven't really worked through the problem yet. I'm sorry.
No, that's fine. That's
I
fine.
have
Yeah, sure.
I have an idea on why we might think that.
Mm-hmm.
So it said that the dropout whatever was cut in half, and then after it was cut in half, it was 17. So I 17 times 2 is 34. So if 34 was cut in half, it would be 17. So like if you multiply 17 times 2, it's 34, which would undo the cutting in half that we talked about.
Yeah, that's right. So you can kind of guess that yeah, as it was cut in half, then the rate, or I mean the graduation rate, could be 34, could have been 34 rather, the previous year. But the thing is, again, we don't really have complete information. Yeah, as a mathematician, we can say that yeah, it should be 34. But if you are trying to interpret something, trying to find a result or trying to make a conclusion, then there is a problem because uh, clearly we don't really know uh, the number of students actually got their graduation through that process. They might have, as now you can see the solution. That's kind of um, giving us rather an idea that the graduation rate should be close to 34, but it might not be exactly 34 simply because there could be a change, here and there. But yeah, as a mathematician, you could say that it should be 34. So that's one thing in maths we often try to ignore. I know some of you are from English department, and I guess you have seen before, or you will see in future, near future, that this interpretation, even in maths, is really important. You need to have complete information. You need to have all those informations, because one or two students here and there, getting dropped, having changed their school and doing other things, this could actually lead us to a different result. But yeah, again, I'm repeating myself that this is a relative change. So this should be around 34, but this might not be completely accurate. Yeah. Okay. So now let's move to example 11 before we go to proportions and rates. And meanwhile, let me write it here so that you can make notes. I want you guys to go through example 6, 9, 10. And let me know if you have any question. Not today, after we finish today. So before we meet the next time on Monday, I want you guys to go through these examples. And if you see, if you can see that something is bothering you, if you are not getting the concept completely, just shoot me an email and we'll discuss it on Monday, or even we can discuss it during our office hours, because I think we can't really go for each and every examples during the lecture. So probably I need to do one and leave the next one for you guys. So sorry for that, because I have time limitations anyway. All right, so before we go to example 11, if you have any question, we can discuss it first.
Yeah, is there any way that we can go over the try it now too that you gave us for homework?
Okay, yeah, sure. So try it now. Okay, I have the question. So it says the US federal debt at the end of 2001 was 5.77 trillion. So that's oh no, sorry, that's try it now too, right?
Yeah.
Okay, so okay. And grew to 6.2 trillion by the end of 2002. At the end of 2005, it was 7.91 trillion and grew to 8.45 trillion by the end of 2006. Okay, calculate the absolute and relative increase for those years. Which year saw a larger increase in federal debt? Okay, so a quick question. Let's go for the first year, 2001 to 2. So a quick question would be, how can you find the absolute change? Anyone?
By subtracting 5.77 from 6.2 for the first part, and then 7.91 from 8.45 in the second.
So you're saying subtracting 5.77 from 6.2?
Yeah, well, I was a little bit unclear on this as well, because I wasn't sure if you do 5.77 minus 6.2, you get the negative number. And then I wasn't sure how to represent shifting it from a negative to a positive, as we did in previous examples.
Mm-hmm.
But
Yeah.
that's what you would do, correct?
So yeah, so the funny thing is, when you are calculating the absolute change, we can use this, right? The two bars, and in between we need to find the change. And thankfully, this guy, this absolute sign, combinedly always gives us positive. So it doesn't really matter in which order you are trying to find the change. That means if you are doing this way or this way, either way, you'll actually get the same result, just because of this absolute sign, right?
Okay. Yeah, I wasn't sure how to draw that on a computer, or type it. Like, I didn't know where the symbol bank was.
Yeah.
So
What is the platform you're using?
I was just typing it through Canvas. So, and I'm on a Windows, like on a
Okay.
PC, so I wasn't sure how to do that, but
Not sure
I'll figure it out.
do that in Canvas, because that's not really a mathematical platform. What you can do, I guess you can use, let me see the keyboard. If you're using a Mac, I guess it should be the same for Windows as well. Just the key um, above the enter button, in between delete and enter.
Oh, I never noticed that. Oh, cool.
Right? You can use
All
that.
right, perfect.
Mhm.
Thank you.
Anyway, no problem. So generally, we actually use the ending value minus the starting value. That means we subtract the starting value from the end value. So that's the general case. But for the absolute one, as we are looking for just the absolute change, the value, not the direction it's going. I mean, whether it's increasing or decreasing, we don't really care. We only need the value. In that case, you actually can use any order. So what should be the value again? Can anyone do it for me? Okay, I can do it, no problem.
It should be 0.43.
0.43. Okay, so that's 0.43 trillion. That's the absolute change. I guess it's for, yeah, 2001 to 2. Okay, and what would be the relative change?
The initial value of 5.77.
I kind of got confused. What did you mean by the initial value? That 5.77, the entire value is the relative change?
I I thought so.
No, no problem, no problem.
I think
Yeah, go for it. Yeah.
you would take the absolute change, 0.43, and divide that over 5.77.
Exactly, yeah. So for relative change, our formula is your absolute value, absolute change rather, divided by the starting one. So if we do that, oops, I can remove this. Okay, so it should be 0.43 and 5.77. Okay, who has a calculator? Do it for me, please.
It comes out to 0.074.
Just give me a second. Someone is in the waiting room. Yeah, sorry. What was that again?
It would come out to 0.074.
0.074. Is that right?
That's what I got.
Okay. Does anyone else have a different what was that again? Relative change? Or is this right?
I just said 0.075. I just rounded the last number
That's
since
all right.
after
Yeah,
4 is 5.
that should be fine. So how many decimals did you take before rounding, of
ask?
course? Sorry?
Oh, it was 0.0745.
Okay, yeah. So up to 4 decimals. Yeah, that should be all right.
Okay.
So let us take 0.075. That looks good. Anyway, that's for 2001 to 2. That's the relative increase, because that's been already said that it's increasing, and that's the absolute increase. Okay. Now for 2005, is it? Yeah, 5 and 6. Okay. What should be the absolute increase?
The absolute increase would be, I got 0.54.
Okay, so if anyone is still wondering what I'm doing here, is for absolute change or for absolute increase, because that's been already mentioned, or you can even eyeball it, that from 7.91 it has become 8.45. That means definitely it has increased. So for absolute change, all we need is the difference between those two and just the value, the magnitude of that. Okay, so 8.45 minus 7.91, and it should give us 0.54, right?
Yes.
Okay, and once again, the relative increase is going to be the absolute increase or the absolute change divided by the initial value. So that would be 0.54 over, what was the initial value? 7.91. And can anyone tell me the value of it?
It's 0.0682.
0682. So we can keep it 068 because the previous one we had it up to 3 decimals. So I'm trying to keep it like that. Okay, now we have finally all the values we need. Now we just need to compare because the question says which year saw a larger increase in federal debt. Now, can you eyeball it? You already have all the answers. Let me separate this from the others. These are the values we have. The red one is for 2001 and 2, and the green one is for 2005 and 6. Now, which one saw a larger increase in federal debt?
2001 to 2002.
And why do you think? Because we can see the absolute increase was more in 2005 and 6, but the relative increase is less. So why do you think we should go for the first one and not the other one?
Well, I wrote my my relative changes as percent, so that's just kind of what I was basing it off of, like the percent increase of each one. I didn't really look at the absolute increase.
Yeah, that's fine. That's fine. Because we actually have two different parts of the question. The first part said calculate the absolute and relative increase, and then it said which one had a larger increase. Yeah, so we are actually looking for the relative one because we had a better percentage, right, during 2001 and 2. So the answer should be yes, this 2001 and 2. Now, any question from this?
Yeah, should we be writing our relative change as a percent or a decimal like you wrote it?
Okay, so if it's not really mentioned, you can keep it like this, as long as you can compare these two by just eyeballing, right? You can actually compare these two, even if you are not converting it to a percentage. But if it's mentioned, then yeah, I can see it's not really mentioned, so I think it should be fine if you keep it like this. Yeah, that's a good question.
Thanks.
Okay, so from next week, what I'll do, I'll share the recordings with you guys. And from today, even I'll actually share the last file as well. I'll share you the files. I mean the things I'm writing up when I'm doing this lecture. So I'll make PDFs and share these files with you guys. And about the videos, I'll probably upload this on YouTube unless it's not really prohibited. I'm not really sure. I need to ask the course coordinator whether it's not allowed, because there could be some privacy issues. If it's not really a problem, I'm probably going to upload it on YouTube. Okay, and that should be available for you guys from Monday. All right, so let's move to, it's already 9:10, right? So I guess let's quickly complete example 11 and then we'll try and see how much further we can go. Okay, so example 11, a basketball player scores on 40% of 2-point field goal attempts and on 30% of 3-point of field goal attempts. Find the player's overall field goal percentage. Okay, so often in a maths question, you have more things, more words than you need. For example, in this particular question, it doesn't really matter whether it's a 2-point field goal attempts or a 3-point field goal attempts. All we need is we have two different categories, and then we need to find the overall percentage. That's it, okay? Although when we'll write, we'll try to use these phrases in their respective places so that it looks good, but we don't really, you shouldn't get carried away by just those numbers, okay? By those extra words. Okay, so the initial guess would be the average looks like the average seems to be 35, right? Don't look at the solution first, because you have 40% in one category and 30% in the other category. So your first impression when you're just watching this for the first time might tempt you to think that, hey, this percentage might be the average of these two. I mean, the overall percentage, because I have 40% in one category and 30% in the other. If I just take an average of this, this looks like the overall percentage would be 35, right? Can you see what's going on here?
Yeah, that makes sense. But it seems you're implying that that's not the right way to do it. So,
yeah, right. Yeah, the way I said it kind of made it obvious that it's not the right answer anyway. All right, so we have, as I said, we have two different categories. This means we actually need the number of the information from these categories. We will have different ways. So we actually use a different word for this. We say weighted average. I'm not sure whether they have mentioned it here, because that should be a new word. I'm not sure, but we use weighted average for those, for this kind of different categories. Anyway, so for this particular problem, we can see the player scores 40% of 2-point field goal attempts. So now the question would be, if he attempts if he attempts 100 2-point field goal attempts, then he scores 40 out of it, right? But can we see how many attempts he actually needed? How many times he actually attempted the 2-point field goal? Can you see that? Is the information here?
No.
Okay, so that is a problem, right? So again, the information is not really here. It's not really a complete problem. So somehow or other, we need to see, can we assume it? Can assumption will could lead us to our final result? Okay, so now see the answer. I'll give you 2 minutes. I want you guys to see and try and see what's going on. If you can understand, if you can make sense, if this actually makes sense to you guys. Okay, I'll give you 2 minutes. Just see and I try to understand what they have done here. And your time starts now. Okay, so sorry to interrupt. Can anyone give me the number of can Can anyone give me the number of students there in this course? I shouldn't be asked this question. I should not ask this question to anyone. I guess we have,
It
yeah, sorry.
should be on Canvas. There should be a list of it. I can check right now under people.
Yeah, I think I can do that. Yeah, that's why I said I shouldn't ask it. Because
37.
37?
Yeah.
Okay, so only 28 is there today. All right, so the number is decreasing day by day. Okay, the next time we'll find the percentage it's getting decreased by, okay? That would be fun. That would be a real life problem, as I promised you guys that I'll try to use these informations and solve real life problems. So I've seen the number of students in this week's lecture. So I'll use these informations. I'll provide you these informations, and I'll give you, let's say, 5 minutes to calculate the number it's getting decreased by. Okay. All right. So let's go to our problem now. So the first question is, do we have enough information? And the
No.
answer is no. Simply because the number of attempts could actually change the result. Let me show you quickly how. So let's say it's example 11, right? So let me write 11 here. All right. So if we attempted, let's say 100 of 2-point field goals, I'd write goals. 40% of that, oops, it seems 44%. Pardon my bad handwriting. 40% of that would be 100 times 0.4, which is, or even as we are comparing it with 100, we can straight away write 40. We don't really need this line, but if you can do that, if you're kind of worried that you might do this wrong. So if he attempted 100, he would have scored 40. But what if he attempted 150? If he attempted 150 2-point goals, he would have scored 150 times 0.4, and this would give us 60, I guess, right? Yeah, 60. And if he had tried 200, he would have scored 80. Now, for 3 different results, I'll show that the overall average will be different. So let's fix the other one. Let's say he attempted only 200 of 3-point goals. Okay. Oops, sorry. And he would have scored 30%. So your intuition should say he would have scored 60 out of those 200. If you're wondering how did I calculate that? So out of 100, he would have scored 30. Out of the other 100, he would have scored 30 more. So clearly, even though I didn't really go for any calculation, I can see he would have scored 60. You don't need to do that. You can clearly do this. 200 times 60. Oops, sorry, that should be 30. And you should still get 60, whichever you like. You don't need to go for the shortcuts anyway. So now the overall average would be, so for average, we know, or the percentage, sorry, we should write percentage here. For the percentage, we need the part over the whole amount, right? We have already seen this formula. So if we start with this one, let's say that's our number 1, that's number 2, that's number 3. So he attempted 100 2-point goals and 200 3-point goals. What's the whole, the total number of attempts he had? He had 300, right? 200 from this and 100 from this. So overall it's 300 attempts. And out of this, how many he scored? He scored 40 from this and 60 from this. So overall he scored 100, and this would give us a 33.33%. You can use your calculator and check my answer. And that's for number 1. For number 2, it would be, use this. Okay. Now the whole amount. Okay, so I have 150 from the first category and 200 from the second category. So the overall attempts he had is 350, and out of those he scored 60 from this and a 60 from this as well. So 120. And what would be the percentage? Anyone? Just use your calculator. Am I disconnected? I can't hear anyone.
No, it should be 34%.
Okay, yeah, sorry. 34, okay. And for number 3, we have obviously 200 from the second category and 200 from the first category. So the whole amount would be 400, and he would have scored 60 from this and 80 from this. So 140. And what would be the percentage?
35.
35. Okay, all right. So clearly you can see the number of attempts heavily changes actually the overall percentage. Okay, that's why the question is not really complete. So if you somehow face this type of questions, my suggestion would be to take easier numbers like 100 for the first category and 100 for the second category. But if you do that, you actually, if you just take the same amount, then it would be always 35% though. So you might try different numbers, but even if you try the same numbers, no one can deduct any credit from you guys because the question is not complete either. All right, so any question from this?
Pretty clear to me.
Now, why do you think we tried this problem? Anyone?
Because the answer could change depending on the information.
Exactly, very good. So you need to take care of the informations you have, okay? Or if you are assuming something, try to assume in a way so that it actually gives you the right result, because you can clearly see only the percentage might not be enough. That's why we actually tried this, okay? So I'll keep this screen on for a couple of more minutes and I'll go for the next topic. Meanwhile, if you can still find any question from the the topic percent, we can discuss it. Otherwise, we'll go for the next topic, which is proportions and rates. And this will be really interesting because you have already used it several times, I'm pretty sure, but you probably didn't think that it could be a topic in your course. Okay, not everyone, but that could be a case. When I first learned this thing, I thought, hold on, I have done this before. Why am I learning it now? So this is because you will see we'll have more complicated problems after we just go past the basic concept. Okay, so what is a proportion? If I ask you, what do you understand by this word proportion? Of course, if you have ever heard this word, what can you say about it?
It'd be like the equivalent of one amount of a thing to another. I don't know how to put it in words. It's just one of
No,
those
you
concepts
are
I've had
actually
for a
doing it
really long
right.
time.
Yeah, that's right. Yep, very good. So um, you can actually say that you are taking equivalence relation. You are considering equivalence relation. Yeah, you're absolutely right. So when let's say I have let's say I'm driving a car, that would be a really good example. That's something you can relate this if you have a vehicle, or if you have seen this. Obviously, I guess you have experienced this. You have a car and it has a mileage, right? When you have bought it, or if your father or mother has a car, you'll often see that they're saying my car has a mileage of 90 miles. Okay, now that means for each gallons it takes you up to 90 miles on an average. So how did you get that? We can get that by taking the proportions out of the uh, uh, distance it's covering and the amount of fuel it's actually taking. So let me make things clear for you. So when you first started this car, let's say you have a full tank of fuel, of gasoline, okay, and it has a 0 miles. That's a brand new car for you. So after 25 miles, you can see your tank is 2.5 gallons less than it had before when you started. So that means when you travel, I guess 25 looks pretty bad. That's not the car you want. So let's say 40. Yeah. So
Oh man, 25 is bad now? Jeez.
sorry?
It's like 18.
No, if the mileage is 18, that's fine. But if I had 25 here, the mileage is way below that. That's why I said it's bad. Okay.
Oh, okay.
So after 40 miles, you can see the fuel is 2.5 gallons less than it was before. So that means if you divide this, what would be the result? Let me use my calculator without wasting any more time. 40 divided by 2.5 is 16. So this proportion gives you an idea that this car has a mileage of 16. That means if you fill up your tank by just 1 gallon of fuel, it will take you 16 miles with that fuel. So that's what proportions give us. you actually travel for 40 miles. Try to pay attention to this. You actually traveled for 40 miles, and that cost you 2.5 gallons of fuel, of gas. Okay, so that means if you had just 1 gallon of fuel, you would have made it up to 16 miles. So that's what proportions give us. Now, how did I get that? The thing is, you always want to find it for a unit. That means for one single unit. On this occasion, we are considering gallons. That means we are looking for what it give us, how many miles it would take us for just 1 gallon. As I said, we always want it for a single unit. Whatever the unit is, it's whether it's a gallon, whether we are working with meters, whether we're looking for different units, doesn't matter. We want to express it and find the value for a single unit. So that's why we divided it by 2.5 so that we can get it for a single unit. And that's giving us the mileage for our car. Okay, so I think we should stop here. And this part would be really interesting because, as I mentioned, I'll try to use a real life problem so that you can actually kind of feel what's going on here. Okay, so yeah, that's it for today. And for Monday, I think I have already mentioned it, but I want to reconfirm it. Yeah, so try and see example 6, 9, and 10, and that's from percent, and example 12 and 13 from proportion. Okay, so just go over these 5 examples and see if you have any question or if you can understand what they are doing there. Okay, all right, so have a great weekend and I'll see you guys on Monday.
I had a quick
Thank
question.
you.
Yeah, sure. Yeah.
For the examples, are we solving them or just reading through them? Sorry.
Yeah, so when I'm saying that go over this, so the ideal technique would be, or what I would do is to hide the question, hide the solution, try to solve it by myself, and then try to see whether I'm doing it in the right direction. But again, you don't need to do that. If you have enough time, then go for that. Otherwise, just try to see the solution and make connections with the formulas, how they have used it, why they have used it, try to interpret those.
Okay, thank you.
Take care.
Have a good one.
You.
You too.
Yeah.